through this, I have certain questions that I want to go over, and then any questions you would also like to go over, we'll go over those. So make sure you are paying attention, following along, writing stuff down. On the first objective, we're going to start with number 5. With number 5, this is solving multi-step equations. We need to combine our like terms, and when we do that, these are going to cancel. So we get 0 equals 0. And that is a specific type of solution. Does anyone remember what type of solution that is? Not undefined as a slope. 0 is also a slope. No solution is a type of answer, but that's not this answer. It's like no solution. If these numbers are the same, this is infinitely many solutions. So anytime you solve an equation, you get the same answer equals the same answer, whatever those two numbers are. It's going to be infinitely many solutions. Do we have any questions on that one? Caleb?
Where do we get that from? When we start doing that?
The infinitely many? That's something we did at the beginning. I don't think you were here before that.
Just put
IMS. You could write it out if you want. Infinitely many solutions. For number 8, we would need to distribute this. So we have positive 4 plus 28x minus 4x equals 4 plus 7x. Then we could combine like terms. So on the left, we have 28x and 4x. So if we combine them, we get 24x. Looking at just this, we have different constants and different coefficients. So I know that this is going to give me one solution, x equals some number. We just have to figure out what that number is. You have a choice of what you want to move. I'm going to move 7x to the left and 4 to the right. Excuse me, by subtracting. So this would give me 17x equals 0. We could divide both sides by 17 and get x equals 0. That would be one solution. Do we have any questions on that one? Right. Last one that I have chosen is number 10. We're going to do the same process, except now we're going to distribute twice on both sides. So this would give us negative 24n minus 24 plus 6 equals 4 minus 24n plus 2. Then we could combine like terms on both sides. So on the left, you have numbers we can combine, negative 24n minus 18. And on the right, we also have numbers or constants we can combine. Gosh. I don't know.
I'm sorry now. I didn't have time.
So looking at this one, we have the same coefficient, the number in front of n, but different constants without doing anything else. I know this is going to be no solution, but we can work it out just in case you Did he see that, or did he know that? So from this, I can say that this is no solution, but if you didn't see that, I could start moving things. I add 24n to both sides, and let's say I add 18. I end up with 0 equals 24. This is not a true statement, so this would be no solution. Do we have any questions on that one? Are there any other questions on this page that we would like to see, go over, or have questions about? Caleb? For number 1, we need to divide both sides by 2. So this would give us 17 equals n. Are there questions on this page?
2.
With number 2, we're trying to get r by itself, so we have to get rid of 19 by multiplying it to both sides. This would get rid of the 19 in the denominator. Someone in your calculator multiply that out.
You multiply because it divides.
And throw it in opposite. What would that be if you multiply 11 and 19? Any others?
Four. Last one. No, I lied. 9.
Or now we're going to do the same thing that we did for 10. Start to distribute. We have 14 minus 12a minus 6a equals negative 6 plus 2 minus 16a. Then we can combine like terms. On the left we have variable terms we can combine. 14 minus 18a. On the right we have numbers we can combine. So negative 6 plus 2 would give us negative 4. Here we don't have the same constant or coefficient, so this is going to end up with one solution. We have to solve and figure that out. I'm going to add 18 to this side, to the right, and add 4 to the left. So we end up with 18 equals 8. And then we could divide both sides by 2 to get 9. On to the next page. Next page is solving literal equations. From way back at the beginning of the year, that was us solving equations that only had variables in it, so these will not result in numerical answers. We're going to start with number 14. With all of these, there are different ways to kind of go about this. I'm only going to show one, but if you want to see the other, we can well. One way you could have done this is get rid of your m on both sides by subtracting. But none of these terms are like terms, so when we subtract, we're just moving it to the other side. We have negative a equals, and I'm going to rewrite this so it's in alphabetical order. Negative m plus n plus p. Then we have to get a still by itself, so we have to get rid of the negative. Since these are multiplying, to undo that, I can divide each of these by -1. And that would give me a equals m minus n minus p. Do we have any questions on that one? Yeah.
How do we, we're dividing variables. When we do anything with variables, they do translate to one all the time.
There is a 1 in front of them unless you see a different number. So these each have a 1 in front of this, which is why we can divide it by -1. Other questions on that one? The next one I want to do is number 20. So in this one, we are solving for x. X is in our numerator, so we have to get rid of our denominator before we can touch our numerator. So to do that, we're going to get rid of this by multiplying both sides by w minus v. Try if you need to. So when we multiply w minus v on both sides, this denominator and this cancel. I'm going to rewrite this so I have u times w minus v equals k plus x. Then if we're trying to get x by itself, we need to move k to the other side by subtracting. When we do that, none of these are like terms, so I can just rewrite this as u times w minus v minus k. Or I could distribute the u and have u w minus v minus k equals x. Both of those I accept. Do we have any questions on that one? Let's see. Are there any others on this page that we would like to see or go over and have questions about? For 19, if we're trying to solve for x, we need to get rid of the r, the d, and the c. So we're going to do the opposite, get rid of these two first because it's not directly connected to x. So we can add r and d at the same time to the other side. And I'm going to rewrite that in alphabetical order. So this would be d plus g plus r equals cx. And then to get x by itself, I'm going to divide both sides by c all at the same time. So x will be d plus g plus r all over c. Questions on that one? Or any other questions we want to go over or see on this page? Page 17. 417, that looks complex, but because we're asked to just find x, all we really need to do is move c over. Some of these, they look more complex than they really are. So if we're moving c over by subtracting, we have x equals, and I'm going to rearrange this, negative c plus y minus d over r. And that would be our answer. Other questions on this page? If not, moving on to the next page. So Unit 2A, these objectives are in a different order than how we took them, tested them, but that's okay as long as they're all there. So this first one is on slope. So we need to remember a couple things. Slope is your rise over your run, your y's over your x's, always up or down before left or right. So you have to find points on this graph that cross these grid lines exactly. Some points that do that are these ones. Be careful that whenever you count the slope, make sure it applies all the way throughout, because if it doesn't, that's not your slope. And then if we're counting y's over x's, I can either go down 3 and to the right one, or I can go up 3 to the left one. Down and left are both negative directions, but if you only have one of them, you're going to get a negative. If you have both, you'll get a positive. So this is going down 3 to the right one. There will be negative 3 over 1, but we can simplify that to just be negative 3. Do we have any questions on that one? For number 24, this is a vertical line. So anytime you see anything with slope, writing, graphing, something with a vertical or horizontal line, write your formula somewhere. And remember that stands for horizontal lines have 0 slope and are y equals. Vertical lines have undefined slope and are x equals. In this case, this is a vertical line, and we are looking for the slope. So the slope would be the u, the undefined. Have any questions on that one? M is your slope. That's your variable for slope. For 26, we are now given points instead of a graph. So we have to find this algebraically. And we need to know how to find the slope algebraically by using this formula, y2 minus y1 over x2 minus x1. We will need to know this because it will not be given to us. If you need to label these points, x1, y1, x2, y2. And then go ahead and subtract. So here, our y2 would be negative 18. We're always subtracting. And then our y1 is another negative 18. All over, our x2 is 3. We're subtracting. And x1 is 2. So for subtracting our numerator and our denominator, the negative 18 minus a negative would become negative 18 plus 18. And those would cancel each other out, leaving 0. 3 minus 2 would give us 1. And if I simplify this would just be 0. So our slope here is 0. Another way we could have figured that out is these 2 points share the same y value. That means they have to fall along the same line. And if they fall along the same horizontal line, that would be a y equals where your slope is 0. Questions on that one? For 28, this is given to you in slope-intercept form. So you just need to be able to determine which of these numbers is your slope, which is this one. So we can say m equals negative 4. Our slope is negative 4. For 30, this is not in slope-intercept form, so we would have to convert this back into slope-intercept form. First, by subtracting x on both sides. We have 3y equals negative x minus 9. And then divide everything by 3. So we have y equals negative 1 over 3x, or negative x over 3, those are the same thing, minus 3. However, that equation does not answer our question as to what the slope is. We still have to look at the 2 numbers and write out what our slope actually is, which is negative 1/3. Questions on 30? Caleb?
So this is it's always gonna be like
The number in front of x. If it's asking for slope. Are there any others on this page we want to see or go over? Yeah. 29. For 29, this is going to be similar to 30. We're going to move 2x by subtracting. We have negative y equals negative 2x minus 3. And then to get y by itself, we're going to divide. Remember that this is really negative 1y, so we're going to divide everything by negative 1. To get y equals positive 2x plus 3. And then your m, your slope, would be the number in front of x, so 2. Any other questions on this page? Okay. Divide the numbers here. We're dividing just the numbers. The x just comes next to it. We're dividing negative 2 and negative 1. On to the next page. This objective is you're writing equations, writing linear equations. We just did this not too long ago. This first part is writing it from a graph. So for 31, this is a horizontal line, so I'm going to write my quotes again. If this is a horizontal line, I know my slope is 0, and I know this has to be a y equals. So I'm going to look on my y-axis and find where this line crosses my y-axis, and that number would be what my equation is, y equals negative 5. have any questions on that one. (32) is a diagonal line, so it's not going to be one of these. We do need to find the slope and the y-intercept. Y-intercept would be the easier of the two because we are looking for where does it cross the y-axis. So that would be at -4. So in our slope-intercept form, we know it's going to be y equals some slope. We don't know what that is yet, so I'm going to leave a space and write x. And then our y-intercept is at -4. Then to find our slope, we have to find points that cross the grid line exactly. So as we start looking for points, all of these points work and are consistent throughout. So if we count that, we're going up 2 to the right one, and we can simplify that to just be 2. So our equation would be y equals 2x minus 4. Questions on that one? For the next section, 36, you are given your slope and y-intercept, so you just have to write those two together in your slope-intercept form. So this would be y equals -1x, or just -x, minus 4. So for that one, there's no real work for you to do, you just have to put them together in the right order. Any questions on that one? (38) is kind of like what we were already doing. We need to get this back in slope-intercept form. So subtract 5x on both sides. We have 2y equals -5x plus 4. And divide everything by 2. We have y equals -5 over 2x plus 2. And that would be our equation for that. Do you have any questions on that one? For number 40, we're going to go back and use our point slope formula. Y minus y1 equals m times x minus x1. This is also something you will need to know because it will not be given to you. So for number 40, you are given a slope, you're given a point. If you want to or need to label them as x1, y1, and m, you can do that. And then we're going to use the points and the slope and put it into this format. So y minus our y1 is 4. Our slope, or our m, is -6. X minus our x1 is -1. You could change the negative or negative minus to a plus already. I'm going to do that next. We have y minus 4 equals -6. Then in parentheses, x plus 1. Then we would need to distribute the 6, -6. We have y minus 4 equals -6x minus 6. And our last step would be to get y by itself by moving 4 over to the right. So y equals -6x minus 2 would be our final equation. Do we have any questions on that one?
What was the second step?
So put everything in first, and then we made the negative minus a plus. Then we distributed, and then we added 4. 42 is similar, except we have to find the slope first. So we need to go back, do our y2 minus y1 over x2 minus x1. So that would be negative 2 minus 2 all over 2 minus 3. So that would give us negative 4 over negative 1. And we could simplify that to be positive 4. After we have our slope, we can choose either of the 2 points to put back in our point slope formula. I'm going to choose this first one because it doesn't have any negatives, but either one would work. So this would be y minus 2 equals 4 times x minus 3. And then we could distribute. So y minus 2 equals 4x minus 12. And then add 2 to both sides. So our final equation would be y equals 4x minus 10. Do we have any questions on that last one? Or other questions we want to go over on this page? On the next page, we're now doing graphing. So we're going to start with 43. This one we need to convert into slope-intercept form. So subtract 3x on both sides. We have negative 2y equals negative 3x minus 4. And then divide everything by negative 2. So y equals positive 3 over 2x plus 2. And then we can graph this. So we would start at our y-intercept positive 2, use our slope and go up 3 to the right 2 as many times as possible, as well as down 3, left 2 as many times as possible. And then connect your dots to make a line. For these, you will have access to your calculator, so you can always double check your work and stuff like that in the calculator, as well as your rulers if you need it. Do we have any questions on 43? Skipping down to 47. This is another horizontal or vertical line. So I'm going to write my whole dots one more time. Since this is an x equals, I know this is going to be a vertical line. So when x equals negative 3, I'm going to make a vertical line through that point. questions on that one? Yes. And then 48. If we were to start graphing this, it's already in slope-intercept form. We start at -2. Our slope is -1, so we're going to go up 1 to the left 1 as many times as possible. And down 1 to the right 1 as many times as possible. And connect. Questions on that one? Are there any others on this page you want to see or go over? If not, go on to the next page. Intercept is the last objective in Unit 2A. So starting with 49, we're looking for the x and y intercepts, and when we find them, we're going to write them as ordered pairs. So for 49, where this line crosses our x and y axis will be at 2 and 3. So our y-intercept would be at the point 0, 2, and our x-intercept will be at the point 3, 0. And that is it. Any questions on that one? For 50, same thing, except this only crosses the y-axis. It does not cross the x-axis at all. So for our y-intercept, that would be at the point 0, 6. For our x-intercept, we could say none, and A doesn't exist. What we could not put is 0, because that would mean there's an x-intercept at 0, and that is not the case. Questions on that one? If you had a vertical line instead of a horizontal line, these would be switched. You would have an x-intercept but not a y-intercept. We're going to jump down and do 55. Now we're doing the same thing, finding the intercepts, but now we're doing it algebraically. So if I wanted to find my y-intercept, I would have to put 0 in for x. And then start to solve. So if I put 0 in for x, -3 times 0 would become 0. This would just become -9y, the 0 would go away. And then we could divide both sides by -9. So y would equal -4. We're still going to put these in as ordered pairs. So that would be the point 0, -4, because x was 0. Then when we go to find y, I'm going to skip some of the steps. If you know that you are putting 0 in for x, in for y, and that 0 times anything would become 0, so that term would disappear, you could really just write -3x equals 36, skip these first two steps, and solve for x here.